The Archimedean property is a fundamental principle of real numbers. It states that for any two positive numbers a and b, there always exists a positive integer n, such that n times a will eventually meet or exceed b. Let's visualize this on a number 9. We can represent b as a target distance from the origin. Now, starting from 0, we can take steps of size a. We increment our multiplier n with each step. No matter how small a is or how large big is, the cumulative distance eventually crosses the target. Thus, we have found an n such that na is greater than or equal to b. To summarize this logic, for any given a and b, there must exist a positive integer n that satisfies the property, its guarantee of existence. Now let's look at the formal proof. We begin with a contradiction. Assume the property is false. This would mean that for some a and b, na is less than b for every possible n. Under this assumption, let's construct a set S. This set contains all values of the form b minus na. By our assumption, this set consists entirely of positive integers. By the will-order principle tells us that any non-empty set of positive integers must have a smallest element. We will call this least element L equals to b minus ma. But notice what happens if you look at the next term in the sequence. b minus m plus 1 into a should be in our set S. However, calculation shows that this new value is eventually smaller than our supposed least element L. Well, this is a direct contradiction. L can be the smallest if we just found smaller element. Since our assumption leads to a logical impossibilities, the assumption must be false. Therefore, the Archimedean property is proven to be true.